integrated system for driver training and assessment using interactive education tools and new training curricula for all modes of road transport. Traffic crashes are the single greatest killer of 15 to 24-year-olds. In every crash and fatality statistic, 16 to 24-year-old drivers are greatly overrepresented, and they also pose a greater risk to themselves, their passengers, and to other road users compared to other drivers. Young drivers' high crash rates primarily result from immaturity, lack of experience, impairment, and lifestyles associated with their age and their gender. Traffic participants are a heterogeneous population. They range from car and motorcycle to truck drivers. All drivers need to be trained in a specific way. Besides the fact that their training needs may differ substantially, they still have several commonalities. These commonalities call for the use of new modular tools and the establishment of new integrated curricula for their training. The problems of the most representative driver categories are: currently, novice drivers of passenger cars have no possibility to enhance risk awareness and train other higher-order skills. Motorcycle drivers have currently no experience on using safety equipment such as ABS and ASR. Additionally, they have low experience on driving different types of motorcycles. Traffic scanning errors prevalence is also very high among them. Heavy vehicle drivers get most of their experience on the road and keep being highly involved in specific accident types, for example, drowsiness-related accidents. Practical training of emergency vehicles drivers is usually limited to closed courses. Still, each police car is on average once per year involved in an accident. Learning to drive demands a lot of practice before expert levels are reached. In comparison, vehicle handling skills are relatively easy to master in only a few hours, while skills such as anticipation of potentially hazardous traffic situations require years of practice. There is a pan-European consensus on the fact that driver training needs to expand away from its current focus on controlling the vehicle in traffic. Training now needs to cover higher-level strategical factors, such as journey-based decisions and the ability to realize and cope with the way that personal traits affects driving behavior and risk acceptance. TrainALL project is a European co-funded research project under the 6th framework. TrainALL is coordinated by the Centre for Research and Technology Hellas, Hellenic Institute of Transport. The TrainALL activities are carried out by a consortium of 17 European companies and research centres. TrainALL project aims to develop an integrated single-platform modular, computer-based system for land-based drivers. The system comprises of multimedia (SW), driving simulator modules, virtual and real simulators, as well as architectural guidelines to solve compatibility issues. TrainALL addresses all types of drivers: drivers of passenger vehicles, motorcycles, trucks, and emergency vehicles. The developed system is designed to be cost-effective, adequate both for training, assessment, and monitoring of the driver, and includes all modes of operation: pre-trip, on-trip, emergency handling. Driver behavioral models are built based on the driving style of actual drivers while they are driving through certain scenarios on a simulator. Profiles are then anonymized and used as natural traffic participants in driving simulator scenarios for other users. This module offers a realistic solution for the surrounding traffic of the simulation, as the participants do not drive necessarily obeying all traffic rules. In the context of professional driving, often a co-pilot is involved, for example, fire brigade, police emergency driving, etc. The driver and co-pilot must be trained to interact and properly cooperate with each other while facing complex traffic situations and often communicating through a radio. Training a team is not feasible because the visualization is driver-oriented. Therefore, training contents technical solutions and training methods were developed to train both within one simulation. The combination of virtual reality systems with driving simulation systems can greatly enhance their capabilities, particularly for training applications. Within TrainALL, an abstract interface between driving simulation systems and virtual reality environments was developed together with a toolbox for creating the interior of virtual reality vehicle mock-ups and for coupling them with the physical parts, steering wheel and pedals. To improve the realism, a new audio system and rear-view mirrors were implemented, as well as a mechanical parametric mock-up to quickly configure among various types of vehicle geometries. Different models of a virtual instructor were developed. The simplest procedure was an automatic protocol after the simulated ride, supporting the instructor in his/her evaluation task. More sophisticated methods include an immediate feedback during runtime of the simulation. Also, a high-end solution is applied where the actual assessment of the driver's performance leads to variations in the sequence of simulation scenarios during runtime. Pros and cons of different feedback modes were discussed and evaluated. The Dynamic Scenario Management module aims to adapt the training sessions to the individual needs of each trainee. Through it, the TrainALL demonstrators will be able to adjust the scenarios running on the profile and behavior of each trainee. The rapid development of ADAS encounters problems in the use of such systems. In the future, one important application field of simulation will be the demonstration of the system functions and the training on how to operate them. The objective is to make drivers able to obtain maximum benefits in terms of comfort and safety from ADAS and IVAS through dedicated scenarios. Enhanced reality means to enhance certain features of the driving environment in the simulated scene that are either not visible or cannot be highlighted when driving in reality. Relevant objects, which must be recognized in an actual situation, can be highlighted in order to direct the driver's perception to the relevant part of the driving scene. From learning theory, we know that effective training should take into account the performance level of the trainee. The adaptive training module aims at the development of a new architecture where scenarios can be linked to each other during runtime of the simulation. The decision which scenario will follow can be triggered by any variable like performance in the previous scenarios.